Number 1. All right. Questions 1 and 2. Hydrated copper sulfate. That looks fine to me. And they didn't say how many. Which of the following is exchanged with the surrounding environment when copper sulfate is heated to close system? Exchanged. So heat goes in. So technically heat is exchanged, it goes in, but that's not what they want you to say. And when you say heat goes out, you are technically putting heat goes in. Not a great question. Okay, so technically heat is correct, but I know they don't want you to say that. Because heat's going in, not heat going out. B, water is going out, yes. Here, it can't be, which of the following is exchanged with the surrounding environment? That means it's going out. So the solid stays in the crucible. Did they say crucible? No. So that can't be right. So heat's going out, and this is what you started with, so that can't be right either. So the answer must be B, even though it's A and B. Just colour that one in. Check the mark scheme. And the mark scheme is A. What a great start. Oh, in a closed system. Oh, that's nasty. No wonder people got this one wrong. All right, this is a warts and all. I got that one wrong, even though I knew it was A, okay? Because I didn't pay attention to closed systems, so gas can't escape. So that must be wrong, and A is correct. Ouchies. This is a really good exam because no one actually got 100%. Yeah, me included. All right, next one. Determine the oxidation number of sulfur in copper sulfate. So copper sulfate, we know SO4 is 2 minus, so we can just leave it at that and make that minus 2, so that's a total of minus 8. So that must be a total of plus 6, so it's plus 6. I don't think there are actual distractors in this one. So normally in God mode, you will cross each one of these ones out. But that one's just too straightforward. I'm just going to leave it at that. So I'm going to go B again. And check the mark scheme. And I got that one correct. Okay. Okay, identify which of the following is an essential component of an electrolytic cell. So diagrams, electrolytic, so that's a galvanic. So this one is in here. And you've got a power supply putting the electrons down here. That's the cathode, which is reduction. And because it's electrolytic, you're forcing that to be neg and that to be pos. All right? And so you've got a battery. So the neg pos. All right? So the voltmeter is for galvanic, and so is the salt bridge. The power supply is a must. And there's no reason why you're setting up a standard hydrogen electrode, which would be galvanic as well. So that one's another easy one. Gee, they started off A. The first question was nasty as hell. So that's C. The rest seem to be straightforward. There was a lot of complexity for the first one, and we got that one right. Okay. Identify which polymer contains a carbonyl group. Polyester. Probably. Polypropylene, polytetrafluorine. Well, you know they're not these, all right? And polyester is a carboxylic acid plus an alcohol group. And then that comes off, all right, to form the polyester, so it must be A. So we go to 4 and type A. Again, the next 3 are really easy, I think. Titration is a volumetric analysis method used to, you can't measure the pH. volume of the titrant. Oh, they're asking for words, definitions of words, basically. Calculate the concentration of an identified, unidentified. Has to be wrong. Preparation of a standard solution of a known. Prepare a standard solution of a known concentration and volume. That's what you start with. All right. So really don't like the fact that I want you to know titrant. So the titrant and the titer, or analyte. So you need to know how much of this you used. Is the volume used to determine the volume of the titrant? Well, you do need to know that. It's really about identifying the concentration of unknown solution. Used to prepare a standard solution. It can't be that because that's part of the method. But this is what we're trying to achieve in order to get the unidentified. So this one's a little annoying, to be honest, but I'm going to go for B. And already my confidence won't be up for this one. No one's confidence was up. All right. And the answer is C. Unidentified, of an identified solution. That's unknown. So they've screwed you up on the words here. So this is part of the method, and this is part of the method. And so calculate the concentration of an. Okay, it's identified. It is identified, but it's unknown. Okay, so of an unidentified. Okay, you have to know what the solution is. Not necessarily, actually, it depends. That one depends. Okay. So what is that? 6. What did I write? 5 is, I wrote B. And it's actually C, so I got that wrong as well. Yeah, okay. Read your questions carefully. All right. Having a shopper. By the way, I did no prep for this, and I am aware of 2 of the questions that everyone got wrong, but I haven't read any of these previously. Any of those, only the 2 problem ones that like only 2 students in Queensland got correct. The equivalence point of an acid-base titration occurs, and it wasn't necessarily the 2 that got 100% either, because no one got 100% for this exam. The equivalence point of an acid-base titration occurs when you want it to be that. The pH never stops changing. The indicator changes color, which is why you're hoping it's this. The titrant completely neutralizes the analyte. Is also correct. So the equivalence point is when the titrant completely neutralizes the analyte, and it may or may not be. You may have chosen a bad color. And so D would be, this is nice and tricky. I'll go 6D. Again, it's more about the destructors can be good. Just one little word. Just trying to trick you really. And 6D. Okay. All right. I do like question 1. I think that's a nice, nasty one. As you can see, I'm doing these rather flippantly and rather quickly. You should do a better job than me, guys. I haven't done organic chem since last year, so I don't know. I'm not really up to it. I'm up on it. I forget things easily. Okay, so question 7, which is an optional principle of green chemistry. A little annoying they put this in because this is not useful for 2025, so they really should just start phasing it out. And it's just memorization. They're moving towards electronic exams, open book. Take the textbook in with you for IB by 2030. So ATAR is going to eventually, the whole world's going to follow through, and stuff like this is just silliness. Avoid chemical derivatives would be good if it's possible. Decrease energy efficiency to increase energy efficiency. You want them. And you want atom economy to be 100%, so that's wrong. So the answer must be A. So we go in there, and 7A. All right. Okay, I'm being a little bit flippant about this on purpose because I expect you to do a better job than me. So I am Being a little careless, even though I am doing God mode here. Anyway, determine the UPAC name. 1, 2, 3, 4. That's butane. Carboxylic butanoic acid. It's carboxylic acid. There's no double bond. Oh, there's no alcohol or just a double bond. There's none of that. And the funny thing is, half the people get these ones wrong. I don't know why people are so bad at naming. It's not just ATARs. Every syllabus in the world, if you read other sites, other subject reports from other syllabuses around the world, even the basic stuff, people just can't do it. Okay, polytetrafluoroethene, which is one of those ones you're meant to remember, and this one as well. Okay, so tetrafluoroethene, tetraethene. And this is polypropylene. So this will have a CH3 group up here. And there'll be other there will be H groups there. So there's a lot of, there's sort of branching here, whereas this one here will line up better and have a lot more London dispersion forces. And this will be a little bit awkward with spaces. It's sort of more branching in a funny way. Then higher melting point's got nothing to do with being reactive. Fluorine atoms form stable. That's got nothing to do with the fact it's high melting point. It's got to be London dispersion. Dispersion forces between closely packed up. Yeah, perfect. Dipole. Oh, that's a tricky one. Between fluorine and carbon atoms within the fluorine. No, they have no access to that. So I should check that because it would be a polar bond. Interaction between the fluorine and carbon atoms within the fluorocarbon chain. Within the fluorocarbon chain doesn't make any sense. Interaction within, it should be between, if they were trying to get to that point, but there will be this like force field of fluorines and you wouldn't be able to access the carbon chain. So 9C, make a commitment there before I check my answers. Yeah. KA, acid represents the pH of an acid solution. No, could be a strong acid. That doesn't make any sense. I don't even want to look at that. Strength of an acid solution, absolutely. Concentration, no, of course not. It's not concentration. Conjugate acid pairs, you don't know what sort of acid it is. It could sort of be the pH because strong acids do have Kas. So this A is sort of correct as well. But this is a far better explanation of how much the acid dissociates. So it really is about 10 being B. So I'll just lock that in before I check what the answers are. So it's sort of a good distractor, I guess. Yeah. Okay, Bronson-Lowry. Acid. What is a Bronson-Lowry acid? I don't know. I'll just do water. Has to give off H+. All right. Okay. That's doable. Accepts a proton to form a base. No. Donates a proton to form its base. Yes. Accepts a proton. So this is the acid. This is the conjugate base. So accepts a proton to form its conjugate base. No, it releases one. Donates a proton, oh, here we go, to form its conjugate base. Okay, something wrong here. Donates a proton to form its conjugate base. Acid conjugate base, correct. Donates a proton to form, oh, so the base, it's got to be conjugate base, not base. Okay. That's a nice one. I'm a little annoyed though that they're just, it's all about word games, really, and it's not really and memorization. So I don't know. can't wait till they start. What is this? 11D. They're all about word games. They're not about, it's about tricking you with word games. These ones. So, whatever. It is what it is. It's the game you have to play. All right. The following the equilibrium law expression for a specific reaction. Determine which is the product. So you can look it up in your data booklets, products and reactants. So determine which of the following is a product of this reaction. This one or this one. So H2O is here. CO2. Oh, got liquids and gases. Interesting. So this is a heterogeneous reaction. And for heterogeneous reactions, we move solids and liquids. And even though we have CO2 over here, we can't have the reactants because we're looking for products. And this one here is a liquid, so we'd remove it, and so it'll be A. Well, that's a good nasty one. Very nasty. 12A. There's a couple in here I like. That one's a good one. 12A. Quite a few I don't like. Word games are a little bit silly. Base, conjugate base. Alright. Does the universe care if it's got base or you've called it a conjugate base? No, it doesn't. Alright. Okay, I got tricked on the first question here because there's so many little tricks to overlook here. So we've got an alcohol getting oxidized. That's a primary alcohol. So that'll go to carboxylic acid. To an aldehyde. And then what are we doing now? Oh, it's reflux. So it goes all the way to carboxylic acid. Nice and tricky. And then if you're adding an NH2 group in there, then you're going to remove the H2O. Form a nitride, which I think is removed from the silver. I had to check for 2025. Tell me the type of reaction produced in X. That's a little bit easier to oxidation of alcohols. There's certainly no none of that, and no esterification because there's no carboxylic acid. Substitution, it is removed. So if they put elimination in there, that would be something that would be nasty. We'd have to analyse a lot. 13B, and I'm not going to because I don't have to, thank God. Probably have to accept both. Alright. Should be another messy situation. You choose the one you think is the most correct, which is oxidation, because that's what's always in the textbooks. That's how they're labelling it. Okay, identify compound Y. Nitride. Oh dear. It's just easier to draw this out. What do we got? Nitrogen with a H to CH3. Can't have an O in there. Can't have O's in there, I don't think. Oh yes we can. Oops. We can have O's in there. We can have O's in there. What am I doing? We must have O's in there. There must be an O. It's like a peptide bond. Oopsies. Oops, that's got that one in there. Alright. So this one matches this one. This one is the NH didn't do the reacting, so it can't be that, so it must be B. Alright. So 14B. Okay. Maybe I'm just out of practice. I should have done a bit more revision or something before I just jumped into this. It's been a week of holidays and no chemistry's in my head, probably a fortnight, nothing else. All right. Identify the single displacement reaction. Single displacement, that's synthesis. This is good because this is a real 2025 edition. This will be a big deal in 2025 onwards, where you have to know all the different names of different types of reactions. This is decomposition. This is a classic setup: A, B, C goes to A, C, B, whatever. And you can see the copper and nitrogen have swapped out just singly, and this would just be that classic double displacement. So we go on 15C. Yeah, you know, that's just basic language. Sorry, I didn't make a commitment first. I don't mind that because it's junior science, although it probably shouldn't be asked because it's junior science. All right, just basic language. Okay, this is way too nasty, and requires way too much analysis. So that's painful. All right, penton 2-ohm, 1, 2, 3, 4, 5. Penton 2-ohm. So students can't even draw these compounds. They don't even know what they are. And you've got to do that before you even consider which parts are being cut and which parts and how big these things are. If you're not going for 100%, I would even skip this. It's just not a non-starter, really. Don't even have room. Hopefully they'll cancel out by atomic weight. It's an owl. So nasty. See, that's a ridiculous amount of work. 6 carbons is 5 carbons is 60. So they're all 60, plus they've all got oxygen, so that's 16. So they're all 76, and then the hydrogens are 2, 4, 6, 8, 10, which equals 86. So that one's 86, so that one matches. That one's just a rearrangement, so it's still 2, 4, 6, 8, 10. So that one's 86. All right. 2, 4, 6, 8, 10, 12. Thank God for that. Just cross that one out. 88. Hopefully this one is wrong too. 2, 4, 6, 8, 10. No, it's not. So it's 86 as well. Damn it. All right. So based on that, no, we're going to have to cut it and work out where the cuts are. So the obvious cut for this one will be here. And that will give us 12, 16, 28, 29. And 29, 86 minus... I don't trust myself at all. I'm even going to use a calculator for this. 57. So there's nothing there indicating that. So pentanol's out. All right. So the cuts are going to be here, which will be reciprocal either side for this one. And so that would be 24 plus 5 is 29. So 24, 5, 6, 7, 8, 9. So again, you'd expect that's 29 or 57 there. This one could be cut here, or could be cut here, and then there'll be this one as well. So that's 15. If it's just that bit, there is a 15. This one here, 15 plus 12 is 27. Plus 6 is 30, 53. Don't trust myself on that. So just grab 16 plus 12 plus 16, 43, which matches that. It's quite large, which doesn't make a lot of sense unless this bit here, if that's cut there, then this bit is 86 minus 53. 86 minus 43, sorry. Oh, and that's a 43 as well. So it'll explain why that's doubly as big, because it's half-half. And then you could add another plus 12 plus 16 and look for a 71, which is there as well. So this seems to be abnormally large. I'd be happy if it was down here more, just be twice the size of that. I don't know why that one's so doubly large. That kind of suggests to me it could be this one if there were 43 bricks, but they're 57 bricks. So I have to go A. I wonder if that's true, if there's an error there. All right, so we'll commit to 16A. All right, question 17. Electrolysis aqueous concentrated, so you will get the chlorine and not the other product. I just don't want to do the work. I said, are you serious? Okay, this is just nasty, really. Assuming they're inerts, the electrons are going this way. This is the cathode, and the electrons are going that way. So this will be negative, this will be positive, chlorine will come off here. So, and the sodium would never react. That's at the cathode and that's the anode, so that's wrong. And so I'd like to look at it as this: the water breaks up into these things, and so the oxygen will come off here and the hydrogen will come off here. So thanks for that. That's a little dog. All right. So D. Oh, he's staying in the video. I don't care. No. All right. 17D. What's your problem? Not too bad. You're getting doggy barks through this. All right. Sky on a treat. Come in here. The electrode and electrode solution of 4 half cells are shown. That is just ridiculously nasty. Gee. Do I have to? You pretty much have to do 4 cells to work this out. That is just crazy. Crazy amount of work. Let me just start here. Iron. I'm just looking at the data booklet. And aluminium. Where are you, aluminium? Okay. They don't have what I would thought just to be completely obvious 1 and 3. And they've got this platinum here, which is non-reactive. And this is a tricky one. So you really have to draw them all out. So super nasty. Electrons going this way. This would be negative. This would be the cathode. So for 4 and 1, you've got iron here and copper. So that's the iron there, which is minus 0.44, and the copper. So the copper's the one that's going to be doing this one, and the iron's going to be reversed. And so the iron's going to be plus 0.44. but it's 4. It's iron going to Fe2+, but it's platinum, so it can't work. So A must be gone. All right, because you can't get the iron coming off because it's a platinum electrode. All right. Crazy nasty stuff, really. So 1 and 2, that one's the most pos, so that's going to work. So again, this is 0.34 and the copper's going up. And the 2 is the iron with an iron electrode. So the iron can actually go to Fe2+ and give you the plus 0.44. So that's going to give you a reading of 0.78. Okay, it's our highest so far. 2 and 3, so you've got iron and aluminium. Aluminium will be very happy to go to Al3+, 1.68, and that will leave this Fe2+ to go to the metal as minus 0.44. So that'll give you a reading of 1.44. Now 3 and 4, aluminium and iron. So kind of the same. So the same deal, the aluminium will come off and do this, and the iron here will join to the platinum and do that. So it'll be the same. And that's doable. So 3's got the aluminium coming off, and 4's got the platinum electrode. Whereas this one, the only difference here is there's a platinum here that's taking the iron, and this is an iron electrode taking the iron. And so C and D look like they're the same to me. And I couldn't tell you the difference. I made a mistake. Iron, aluminium versus iron and a platinum aluminium. The iron is going to join up and be reversed. Yeah, can't tell the difference between the two. Good luck to you. Just choose one, either C or D. We'll just go the first one and go C. 18, I've gone C. The answer's D. No idea. Sorry guys, can't help you with that one. Alright. Knowing QCA, they've just made a mistake. Okay, but I can't verify that. They might have made something I don't here. It's possible. I don't know. Esters undergo hydrolysis to form a carboxylic acid. And by the way, if the computer's gone for D, even if C is correct, you're going to get it wrong. So I got that one wrong regardless, even if it is correct. All right? Yeah, I still get it wrong. Okay, so we're going hydrolysis to form esters, carboxylic acids, and alcohols. I'm getting annoyed with the test now. 19C. Yeah, no wonder no one got this right. This is actually impossible to get correct. It's borderline impossible, even with God mode. God mode can't save you guys on that. It just can't. All right. Okay. Yeah, it can get you top of state and 100%. Though no one actually got 100%, and it's probably because they really did get 100% and the marks are wrong, things are wrong. Probably. That's the only thing that makes sense, because I know the students were hyper intelligent last year. It was unusual and a complete shock that they couldn't get 100%. So anyway, polyprotic acid. It's got to have 3 pluses that can come off. That's a base. That's a salt. It has it's a monopro tick. 20B, gee, they alternate between ridiculously easy and just impossible, or too much work for a multiple choice question. All right. 17 out of 20. Yes, I expect you to get 19 out of 20. I don't know if that's a mistake on QCA's part. That was just some wording I was overlooking. Okay. I'll give you a reprieve and let you get 19 out of 20 for that. People who got 100% probably got way more than one wrong, by the way. So 19 out of 20 is passable, okay?